Okay, the following is the formal definition of a limit, and I'm going to treat it briefly. It is very formal and a little bit hard to understand, quite hard to understand. Anyway, there is a video on Khan Academy that can explain this if you were wanting to go into it deeper, but you would be looking for the delta epsilon definition of a limit. Hopefully you have an intuitive understanding already of what a limit is, and how to work with it, whether from a table perspective or from the graphical perspective, or hopefully the difference quotient perspective, which we did with the first gravity problem. Okay, so here it is in a nutshell. Basically there are two Greek letters here, delta and epsilon. And you can informalize it or kind of understand it by saying that delta represents distance and epsilon represents error. So here's the idea. Remember back on this problem when we were studying x cubed minus 8 over x minus 2? Well, we were trying to approach 2. And you can see from our table that we had used certain values here which were 0.1 away from one another. Now, this is not delta. Delta is not 0.1 per se, but you can kind of think of it that way. So the delta is basically how far away you are from 2. So between here and here, delta would be 0.1, say. And we know the limit actually comes out to be 12, and that, by the way, can be confirmed to be exact. We had estimated it, if you remember on this problem. So the delta would be 0.1 if we choose this value of x. And then it looks like from 12, that'd be about 0.59. 11.41 is about 0.59 away from 12 numerically. So delta would be 0.1 and epsilon would be 0.59. Okay, and the theorem is stating this. If you want your error, your epsilon, to be smaller than that, let's say you want it to be 11.991, then you're going to have to come over here and pick a certain delta. And it's going to have to be something smaller than 0.1. In other words, you're going to have to create a finer scale here if you wish to have more accuracy on the limit. It's common sense, but it is very informal. So if you're willing to deal with a certain amount of error here, then that means you're going to be dealing with a certain discrepancy here, delta. By the way, this is C, in case you hadn't picked up on that yet. And the final 12, well, that's called capital L. Okay. So that's about as deep as I want to go with that. A couple of comments on notation. First of all, we write this as limit with an x arrow c underneath it, and then f of x, and then equals capital L. We usually use capital letters for outcomes on limits. The x minus, or the x arrow c there, can also be written slightly to the right and below, rather than directly underneath the LIN. And this is just something the computer does to me when I'm trying to enter these symbols. It just puts it here or puts it there, and I can't seem to control that. So that's Microsoft Word. Okay, and the way it's pronounced, it says this in the book as well, you're going to read this as the limit of f of x as x approaches c equals, and then L. So in this case, the limit of x cubed minus 8 over x minus 2 as x approaches 2 equals 12. And this one, the limit of sine x over x as x approaches 0 equals 1. And I made a comment there for you to memorize that one because the real purpose, or the real derivation for that is something way beyond this chapter, and it shows up later in the year with series. Okay, so this is your end of your notes. Each day I'd like you to go ahead and write down any graphs you think you'll run into again, write down any formulas or equations that you found new, or maybe something that might apply. Maybe you glanced through the book and saw it later, and so it's time to record it. And then of course here you can see to write 2 sentences about what you learned. Try to do this in a very complete sentence fashion. Try not to make it sound like entirely your own words. You want to have math vocabulary in here. At the same time, you don't want to be copying from someone else. You want to really put down your own thoughts here. Imagine if you're trying to explain this to somebody, if your parents ask you, what did you learn today? And they had a math background. Maybe you could tell them as mathematically as possible what you learned. And this is in keeping with the new Common Core standards that the state is expecting of us. Okay, well I hope you learned something here from 2.1, and stay tuned for more.